Most people overestimate what they can achieve in a year and underestimate what they can achieve in 10 years. It's unclear exactly who first made that statement, when they said it, or how it was phrased. The most probable source is Roy Amara, a Stanford computer scientist. In the 1960s, Amara told colleagues that he believed that we overestimate the impact of technology in the short term and underestimate the effect in the long run. For this reason, variations on that phrase are often known as Amara's law. However, Bill Gates made a similar statement, possibly paraphrasing Amara, so it's also known as Gates' law. Let's check out everything about Gates' law. '8. Moore's law. Gates' law is often mentioned in conjunction with Moore's law. This is generally quoted as some variant of the number of transistors of an inch of silicon doubles every 18 months. However, calling it Moore's law is misleading, at least if you think of laws as invariant. It's more of an observation of a historical trend. When Gordon Moore, co-founder of Fairchild Semiconductor and Intel, noticed in 1965 that the number of semiconductors on a chip doubled every year, he was not predicting that would continue in perpetuity. Indeed, Moore revised the doubling time to 2 years a decade later. But the world latched onto his words. Moore's law has been variously treated as a target, a limit, a self-fulfilling prophecy, and a physical law as certain as the laws of thermodynamics. Moore's law is now considered to be outdated after holding true for several decades. That doesn't mean the concept has gone anywhere. Moore's law is often regarded as a general principle in technological development. Certain performance metrics have a defined doubling time, the opposite of a half-life. 7. Why is Moore's law related to Amara's law? Exponential growth is a concept we struggle to conceptualize. As University of Colorado physics professor Albert Allen Bartlett famously put it, the greatest shortcoming of the human race is our inability to understand the exponential function. When we talk about Moore's law, we easily underestimate what happens when a value keeps doubling. Sure, it's not that hard to imagine your laptop getting twice as fast in a year, for instance. Where it gets tricky is when we try to imagine what that means on a longer timescale. What does that mean for your laptop in 10 years? There is a reason your iPhone has more processing power than the first space shuttle. One of the best illustrations of exponential growth is the legend about a peasant and the Emperor of China. In the story, the peasant, sometimes said to be the inventor of chess, visits the emperor with a seemingly modest request. A chessboard with 1 grain of rice on the first square, then 2 on the second, 4 on the third, and so on, doubling each time. The emperor agreed to this idiosyncratic request and ordered his men to start counting out rice grains. Every fact of science was once damned. Every invention was considered impossible. Every discovery was a nervous shock to some orthodoxy. Every artistic innovation was denounced as fraud and folly. We would own no more, know no more, and be no more than the first ape-like hominids if it were not for the rebellious, the recalcitrant, and the intransigent. If you haven't heard this story before, it might seem like the peasant would end up with, at best, enough rice to feed their family that evening. In reality, the request was impossible to fulfill. Doubling 1 grain 63 times, the number of squares on a chessboard, minus the first one that only held 1 grain, would mean the emperor had to give the peasant over 18 million trillion grains of rice. To grow just half of that amount, he would have needed to drain the oceans and convert every bit of land on this planet into rice fields. And that's for half. In his essay, The Law of Accelerating Returns, author and inventor Ray Kurzweil uses this story to show how we misunderstand the meaning of exponential growth in technology. For the first few squares, the growth was inconsequential, especially in the eyes of an emperor. It was only once they reached the halfway point that the rate began to snowball dramatically. It's no coincidence that Warren Buffett's authorized biography is called The Snowball, and few people understand exponential growth better than Warren Buffett. It just so happens that by Kurzweil's estimation, we're at the inflection point in computing. Since the creation of the first computers, computation power has doubled roughly 32 times. We may underestimate the long-term impact because the idea of this continued doubling is so tricky to imagine. 6. New technology. The media picks up on the existence of a new technology which may not exist in a usable form yet. Nonetheless, the publicity leads to significant interest. At this point, people working on research and development are probably not making any money from it. Lots of mistakes are made. In Everett Rogers' diffusion of innovations theory, this is known as the innovation stage. If it seems like something new will have a dramatic payoff, it probably won't last. If it seems we have found the perfect use for a brand new technology, we may be wrong. 5. The peak of inflated expectations. A few well-publicized success stories lead to inflated expectations. Hype builds, and new companies pop up to anticipate the demand. There may be a burst of funding for research and development. Scammers looking to make a quick buck may move into the area. Rogers calls this the syndication stage. It's here that we overestimate the future applications and impact of the technology. 4. The trough of disillusionment. Prominent failures or a lack of progress break through the hype and lead to disillusionment. People become pessimistic about technology's potential and mostly lose interest. Reports of scams may contribute to this, as the media uses this as a reason to describe the technology as a fraud. If it seems like new technology is dying, it may just be that its public perception has changed and the technology itself is still developing. Hype does not correlate directly with functionality. 3. The slope of enlightenment. As time passes, people continue to improve technology and find better uses for it. Eventually, it's clear how it can improve our lives, and mainstream adoption begins. Mechanisms for preventing scams or law-breaking emerge. 2. The plateau of productivity. The technology becomes mainstream. Development slows. It becomes part of our lives and ceases to seem novel. Those who move into the now saturated market tend to struggle, as a few dominant players take the lion's share of the available profits. Rogers calls this the diffusion stage. 1. The adjacent possible. Now that we know how Amara's law plays out in real life, the next question is, why does this happen? Why does technology grow in complexity at an exponential rate? And why don't we see it coming? One explanation is what Stuart Kauffman describes as the adjacent possible. Each new innovation adds to the number of achievable possible future innovations. It opens up adjacent possibilities which didn't exist before, because better tools can be used to make even better tools. Humanity is about expanding the realm of the possible. Discovering fire meant our ancestors could use the heat to soften or harden materials and make better tools. Inventing the wheel meant the ability to move resources around, which meant new possibilities such as the construction of more advanced buildings using materials from other areas. Domesticating animals meant a way to pull wheeled vehicles with less effort, meaning heavier loads, greater distances, and more advanced construction. The invention of writing led to new ways of recording, sharing and developing knowledge, which could then foster further innovation. The internet continues to give us countless new opportunities for innovation. Anybody with a new idea can access endless free information, find supporters, discuss their ideas, and obtain resources. New doors to the adjacent possible open every day as we find different uses for technology. We like to think of our ideas as $40,000 incubators shipped directly from the factory, but in reality, they've been cobbled together with spare parts that happen to be sitting in the garage. Take the case of GPS, an invention that was itself built out of the debris of its predecessors. In recent years, GPS has opened up new possibilities that didn't exist before. The system was developed by the US government for military usage. In the 1980s, they decided to start allowing other organizations and individuals to use it. Civilian access to GPS gave us new options. Since then, it has led to numerous innovations that incorporate the system into old ideas. Self-driving cars, mobile phone tracking, very useful for solving crime or finding people in emergency situations. Tectonic plate trackers that help predict earthquakes. Personal navigation systems, self-navigating robots, and many others. None of these would have been possible without some sort of global positioning system. With the invention of GPS, human innovation sped up a little more. Do let us know in the comments what you think of this Gates' law. Thanks for watching.